Hello everyone. Today we are going to see the packet delivery in the mobile IP context. That means how packets are delivered to a user which is mobile using the mobile IP mechanism. In the last video we saw what is exactly mobile IP and what are the different entities or terms which are used in mobile communication system for supporting mobile IP. So let's start with the packet delivery. We have seen the example network in the last video in which we saw the different terms like CN, HA, FA, MN, COA, all these terms we have seen. Now same example network is illustrated in this particular figure. Now in this one we will see a packet delivery to and from mobile node using the example network. So what's the scenario? Scenario is that a correspondent node CN, this is a transmitter, wants to send a packet to a mobile node which is now a receiver. Okay. Now one of the requirement of mobile IP is to support hiding the mobility of MN. Now as you can see, mobile node currently is in a foreign network. That means it already belongs to actually home network, that is this network, but currently it is residing in the foreign network. Now this movement from home network to foreign network should be invisible to correspondent node. That was the requirement. Because once we change the network, our IP address will also change, and that means destination address for packets sent by the CN should change. But since we are using mobile IP, those packet will not contain any different destination address, and that means the mobility of mobile node is kept invisible from correspondent node. Okay, so we will see step by step process how these packets are delivered. So let's look at the first step. Step 1, correspondent node does not need to know anything about the mobile node's current location. A sender does not have to worry about what is the location of the receiver. Okay, so when it sends a packet, it sends just like it sends a packet in a fixed network, that is mentioning source address as its own. So let's say suppose this is CN, it will send a packet. Now IP packet has a field such as source address and destination address. Now source address of this packet will be address of CN and destination address is address of MN. Now address of MN is a IP address of mobile node in home network. So IP address belonging to home network will be put as a destination address for the packet. Okay, now this packet is sent by the correspondent node which travels through the router and reaches the internet. Now internet is, as we all know, is an interconnection of several networks as well as several routers involved in it. So they are not worrying about what is the location of mobile node. From the destination address mentioned in the packet, so let me simplify this. From the destination address mentioned in the packet, internet forwards that packet to the home agent of the home network. How does internet find out? Internet finds out the address of mobile node from the destination address mentioned in the packet. Now that destination address is a IP address of a mobile node in this home network. Okay, so this is our first step, forwarding packet to the home agent. Okay, now this router will accept this packet because from the destination address mentioned in the packet, it will come to know that this packet belongs to my network, which is called as home network in our case, and it will accept that packet. Now what happens next? In the step 2, home node or home network finds that mobile node is not in the home network. So when home agent accepts the packet, it tries to deliver the packet within the network. So for that, it tries to find the node within that network which is belonging to the IP address of destination address mentioned in the packet. But it finds out that this node is not present in the network. So what it will do? It realizes that this node is moved to some other location, and that location has a foreign agent. So it will forward that packet through again internet to a foreign agent as shown in the diagram. Like this. Now while forwarding this packet, this is called as tunneling. It tunnels the IP packet through internet towards the foreign agent because mobile node has moved to the foreign network. Now this process of forwarding the packet from home agent to foreign agent is not known to the correspondent node. So correspondent node does not worry about what home agent is doing. Now what is tunneling exactly? Tunneling we will see in detail later on, but right now for understanding, home agent takes the packet. Suppose this is the packet. Home agent takes the original packet, puts it inside the another IP packet. So in short, it adds one more header. A header, new header is put in front of the old IP header. Now in the new header or in the new packet, source address will be address of home agent. And what is the destination address for new packet? Now destination address for this outer packet will be address of foreign agent, that will be COA, care of address of the mobile node. Okay, so this is encapsulation and tunneling. In short, the details we will see later on, but this is how it sends a packet inside a packet, that is nothing but encapsulation, and tunnels it through the internet towards the foreign agent. So that is our step 2. Now foreign agent accepts this particular packet because it realizes from the destination address mentioned in the outer packet that this packet belongs to this foreign network and accepts the packet. Now what does foreign agent do? Let's see that. Now in the step 3, foreign agent now decapsulates the packet. So decapsulation means what it has received? A packet inside a packet. So what it does? Removes the outer packet. So it will obtain an original IP packet which was sent by the correspondent node. Now it again checks the source address and destination address. Now destination address is IP address of MN which is occupied by care of address. Now it realizes that because foreign agent has COA to IP address mapping, so whatever care of address was mentioned in the outer header maps it to the IP address of mobile node and forwards the packet to the mobile node. That is the third step in the packet delivery. So this is how in 3 steps, first, second and third, in 3 steps a packet is delivered from a fixed node called as a correspondent node to the mobile node called as a MN in the foreign network. Okay, so packet is now delivered to the receiver. Now if it is a duplex communication, MN will revert back to the CN giving a reply, or sometimes it may be acknowledgement also. So that will be our 4th step, how MN responds to the reception of a packet. So what will happen in the 4th step? MN sends the packet as usual. As usual means similar to how it sends the packet in the fixed network, with its own fixed IP address as source and CN's address as destination. So if MN is responding, then it will create a packet where source address and destination address will be mentioned. Source address is its own and destination address is of correspondent node. Now destination address is of correspondent node which is a fixed node, so it is not moving, so you do not need to travel through a tunnel. So that path is directly through the internet towards the router of the correspondent node. So that is the 4th step. So in case of communication from mobile node to fixed node, there is no requirement of a tunnel, but in case of communication from correspondent node to mobile node in a foreign network, tunnel is required. Okay, so that is how packets are delivered in the mobile IP context. Now if you can observe, we are not using any different technique or different format for IP addresses. We are using same formats which were used in the fixed network. So this is another pictorial representation of how packets are delivered. You can see step 1, correspondent node through internet to home agent. Step 2, home agent tunneling the data to foreign agent. Here you can observe the blue path is a path of a packet, whereas red path or red lines which are enclosing the blue line is nothing but a tunnel. So red is our tunnel and blue is a packet route of a packet. And in the third step, foreign agent forwards the packet to the mobile node via wireless access point. Okay, since that will be a mobile node, it will be wireless in the most of the cases, so it will be forwarded through wireless access point. And in the reverse direction, again same thing as we have seen in the description. Mobile node sends the packet through wireless access point, foreign agent, internet, and towards the correspondent node. No involvement of home agent in the return path. So home agent is not required in the return path in our example. So that is how packets are delivered. A few questions that has to be asked, or before that we can summarize that. Sorry, mobile IP is not any different format of IP address. IP address that is used for communication is still 32-bit IP version 4 address if we are using IP version 4. So same 32-bit addresses are used. So what is exactly mobile IP? Mobile IP is nothing but an enhancement to at least three parameters. First one is working of IP protocol, in which case in fixed network working is very simple, router to router communication for delivery of packets. But in this case we are forming a tunnel to reach out towards the actual current destination of the mobile node. So slight enhancement to the working, then enhancement to the efficiency of IP protocol. Now what we are doing, we are not generating too many extra messages, we are putting original packet into another packet, so only one more extra packet will be required for each packet. So not much efficiency is degraded, although there is slight drop in the efficiency due to obvious reasons, that additional packet has to be transmitted. Also it has to be delivered over the wireless media at the final end, because wireless media is susceptible to more degradation compared to wired media. And the third enhancement is enhancement in the security issues of the IP protocol. Now because of this encapsulation which is happening at the home agent and tunneling, packets will be more secure and correspondent node will not know the location of mobile node. So that is important security aspect. Correspondent node will never know the location of mobile node because it is kept invisible from the correspondent node. So no tracking possible in case of mobile IP also. So mobile IP is just a mechanism, not any different standard. It's not a different format of any kind of packet. It's just a mechanism to improve the delivery of packets to the mobile nodes. Now what are the problems? Although at first it seems this is a very simple procedure, but there are several problems. What are the problems encountered in this delivery? First problem, how does home agent finds out the foreign agent? We have seen home agent HA tunnels the IP packet to the foreign agent. Now there may be so many foreign agent in the world present. How does exactly home agent knows that a packet has to be transferred to exactly this particular foreign agent? Why not this, or why not any other else? So finding the location of mobile node is issue of home agent now, not the correspondent node. So that is first problem. Then second, how does the MN discover that it has moved? Now how MN will know that it is not currently inside a home network and it should acquire a care of address? So whenever it moves the network moves out of the network, it has to acquire care of address, otherwise packets will never be delivered. So how does mobile node find out that? It has to find out a care of address. That is the second issue. Third issue, what is the what if the foreign agent has a firewall? What's the issue of firewall in this case? Now this is our foreign network. Here it is a foreign agent. Here it is a mobile node. Now mobile node wants to send a packet. Now router, that is foreign agent, this is my foreign agent, has a firewall in this. Now what will firewall do? When it receives the packet from mobile node, it will check source address and destination address. For firewall, destination address is not an issue. The issue is source address. Why? Firewall detects that this source address, which is now IP address of mobile node. Now IP address of mobile node belongs to the subnet of home network. We have seen that during the IP packet delivery. Mobile node's IP address belongs to this network. Now firewall finds out the source address is not belonging to this particular foreign network or this particular subnet, but some other subnet. So it decides that this is a attacker or intruder which is trying to flood the network with unnecessary packet, and it blocks the packet at the foreign agent. So mobile node packets may be blocked at the firewall because of source address being a IP address of the mobile node. So that is the third issue. So can we stop using firewalls because we have to support mobility? That is not a solution. What are the solutions? We will see in the upcoming videos. Now fourth issue, what if mobile node is a part of a multicast group? What is a multicast group? Multicast means a packet is delivered to selected number of nodes. Now multicast group is group of nodes which are part of a multicast group. These are, let's say there are 5 nodes. This is multicast group 1. So whenever is packet arrives for this particular multicast group, a router will forward this packet to all 5 nodes. Now what's the problem if a mobile node is a part of a multicast group? Now let's assume this multicast group is of home network. Here this multicast group is of home network. Now there are 5 nodes in this multicast group. Packet is arrived. 4 of them remains in the home network, but one of them, let's assume this one, moves out of the home network and goes to the foreign network. Now 4 nodes are still in the home network and one node is gone to the foreign network. Now when a packet is arrived, router will forward the packet or broadcast the packet to all the nodes within that group, but one of them will not receive because it is not part of this particular group right now. It has moved out of the group or that particular home network. Now when it moves to the foreign network, now let's assume it has moved to the foreign network. So this node is moved to the foreign network. Now that multicast group is invalid in this foreign network because multicast group will also have a subnet prefix belonging to home network and this foreign network is using some other subnet prefix. So whatever multicast group in the home network is invalid in the foreign network. So it cannot be possible that the node which has moved out of home network will remain in the multicast group when it moves out of the home network. So that is not possible. You will remain in that same group even after moving out. Okay, so there are several such issues which are encountered in the mobile IP. We will see solutions for all these issues in the upcoming videos, but that's all for today. In the next video we will find out answer to this first question, how to find a foreign agent, and how does mobile network or mobile node discover that it has moved. Okay, thank you.